Hi, I'm Myron Lowen, a platform architect at Solidigm and an NVM Express board member. In this video, I'll discuss the NVM Express modifications for I3C feature, including its use cases and its applications within the enterprise and hyperscale data center markets. The NVM Express modifications for I3C are part of the NVM Express organization's goal to align NVMe features with other industry standards. The MIPI Alliance has been working on I3C as an upgrade for I2C for many years. At the end of 2023, PCI-SIG adopted it for the two-wire interface, which is a new name for what used to be called SMBus. SMBus signals are still supported, and the PCI-SIG defined a negotiation flow to dynamically switch the two-wire interface to I3C. NVMe-MI version 2.0 brings full support for the two-wire interface at both SMBus and I3C speeds. I3C will improve the NVMe-MI bandwidth, latency, robustness, security, and efficiency in a way that's backwards compatible with SMBus interface. The NVM Express modifications for I3C enhance the existing benefits of NVMe technology by boosting the speed from 100 or 400 kilohertz up to 12.5 megahertz, with a DDR option to achieve 25 megahertz, providing over 100 times faster transfer rates for firmware updates and large log page reads. An I3C hub architecture is always connected, unlike SMBus muxes, which typically disconnect the SSD for more than 90% of the time. Being always connected allows the SSD to send event notifications instead of the latency polling architecture, so the platform can respond much faster. This also permits all SSDs in an array to work in parallel instead of waiting for their turn to use the bus. I3C maintains the security isolation that muxes offer by requiring all traffic to go through the host platform and eliminating peer-to-peer communications paths. I3C also runs at lower voltages and eliminates the SMBus pull-up resistors to reduce power per transferred bit. And the I3C includes standardized commands for common tasks, such as discovery, config, status, and resets. The most obvious challenge that this feature addresses in the enterprise and hyperscale market is the higher bandwidth, which will enable large data transfers to be completed faster. For example, firmware updates will take seconds instead of minutes. In addition, this bandwidth allows security to be improved without impacting a platform's time to ready. But I think that the most important feature is a safe elimination of the SMBus muxes. Safety and security are achieved by only allowing the platform to drive the clock signal, and thus giving it complete control over the bus. The always-on connected hub technology replaces the muxes, which caused issues with signal integrity, packet retries, limited fan-out, and prevented device-initiated transactions. In addition, the BMC's architecture can be simplified by taking advantage of communicating with any device whenever needed, broadcasting notifications to all devices, and allowing the devices to report events without polling. A platform could go even further by placing multiple devices on a single two-wire channel for reduced cost or for adding more devices through an existing wire harness. I3C is also fully backwards compatible for two-wire buses on all current form factors, simplifying the need for signaling for resets and assigns I3C addresses dynamically to avoid the need for databases of reserved addresses. I3C will immediately improve the management of NVMe storage arrays with tight security requirements. As I3C adoption grows, it will become the base for more development that improves security, power loss notification, hot plug detection, and platform redundancy. To learn more about NVM modifications for I3C, visit the specifications page of the NVM Express website at nvmexpress.org. Here you'll find all the technical proposals included in the NVMe specifications, including TP6037 modifications for I3C, which will become part of the NVMe 2.0 specification. TP6037 includes references to the PCI-SIG, DMTF, and MIPI specifications, which go into much more detail than we had time for in this intro to I3C.